Okay, today's videos, we are moving on to section 5.6, which is the fundamental theorem of algebra. When we're working in section 6, we are going to use some of those theorems that we learned back in section 5 that we've been working with the last couple days. Mostly the rational root theorem. The conjugate root theorem might be helpful in a couple other ways, and Descartes' rule of signs, not so much in this section, but we'll definitely be using the rational root theorem quite a bit. So the fundamental theorem of algebra actually is something that we have been using most of this chapter. We've just never put a name to it. Here's what it says. A polynomial function of degree n has exactly n roots. Okay, and then just a little bit that I'm going to add here. This includes multiple roots. Like if we had a multiplicity of 2, that would count twice, which we've talked about before. And it also includes any complex roots we had, any imaginaries. So we're not just talking about our real roots that we have, the ones that you can actually see if you look at a graph, where we can see the x-intercepts, but we're also talking about the imaginaries and the multiples where we have different multiplicities. Okay, a lot of this section, we're really just going back and solving some more polynomial equations, but in some of these ones that we solve, we're going to have to use our rational root theorem along the way. And you kind of saw a preview to this in 5.5. I think it was the second video you watched, example 2. Here's a problem we'll do together. We want to find all the roots of our equation, x to the 4th plus 2x cubed minus 13x squared plus 10x equals 0. I look at this equation and I see that I have 4 terms. And once I notice I have 4 terms, I also notice that all of my terms have an x. So trying to solve this algebraically, let's factor out an x right away. And we'll see how far we can get. So the x cubed here. Just going to rewrite that. Factor out my x cubed plus 2x squared minus 13x plus 10 equals 0. Remember, you can always double check 2x times x cubed is x to the 4th. X times 2x squared is 2x cubed. X times negative 13x. X times 10. Once I get here, I'm going to look inside the parentheses. I have my 4 terms still. And usually when we see 4 terms, our first thought is hopefully, let's try factoring by grouping. These guys have an x squared in common. These guys, the only thing we have is a 1, maybe a negative 1, since this is negative 13x. Hopefully you're thinking, okay, that's a problem. My sets of parentheses aren't the same. I can't factor this by grouping. And we don't know any other way to factor or to try to solve something like this algebraically other than by grouping. So this is not going to work. I crossed out my factoring by grouping attempt, but I'm going to leave this part here. This is where our rational root theorem comes into play. We factored out our x. So hopefully that tells you, okay, this is one of our solutions. This shows us one of our solutions. One of our roots is going to be when x equals 0 because of our zero product property. I really need to find when this part equals 0. X cubed plus 2x squared minus 13x plus 10. Since we can't factor this by grouping, use our rational root theorem. I'm going to list out my possibilities for the numerator and also my possibilities for the denominator. My numerator, all of my possibilities are numbers that multiply to our constant term, that multiply to 10. So we could have 1 and 10, or 2 and 5. Positives and negatives for each. Our denominator, numbers that multiply to our leading coefficient, which is x, or which is 1 in this case, since it's 1x cubed. Positive 1, negative 1. Our possible roots would be any combination here, which isn't too bad since this is our only possibility for the denominator. Possible roots are plus or minus 1, plus or minus 10, plus or minus 2, plus or minus 5. Now we have to check them. Once we find 1, then we can use our synthetic division to find the rest. We don't necessarily have to check all of them. And actually, it works kind of well if we stop sometimes instead of checking all of them, because we might not have 3 more roots that are all rational. All right, so kind of like what we were doing the other day when we were practicing our rational root theorem. I'm going to go to y equals on my calculator and type in my equation. X cubed plus 2x squared and that was all typing up at the top here. Let's try that again. X cubed plus 2x squared minus 13x plus 10. Go to my table set, down to ask, and then over to my table. And I'm going to check these possible roots. So 1, hey, that worked out well. 1 is a root. Okay, now that I know 1 is a root, I can use some synthetic division to figure out the rest. This root is what goes in my box here. And you could do long division if you wanted to with x minus 1, but synthetic division is a little bit quicker. Again, we write our coefficients in order. Bring down your first number, and then we take that times our number in our box. Add straight down. And keep going. Now don't forget, since we know that this is a root, and we know x minus 1 would have to be a factor, we will end up with a remainder of 0. If you don't, that means you messed up somewhere. Here's our remainder. Here's our 1s, our x's, and our x squared. We have 1x squared plus 3x minus 10. This is actually really nice. This factor is nice and easy. X plus 5 times x minus 2. Because positive 5, negative 2, they multiply to give me negative 10, add together to give me positive 3. So my other roots are at negative 5 and at 2. Okay. Now again, we could have found our other roots here in this problem by continuing to check our possible roots from our rational root theorem. Sometimes though, we won't have all roots. We won't have all rational roots as our solution. We might have irrational, we might have complex in there too. So using our synthetic division is just kind of a good idea to get used to. In the next example, the second option for this one, I will do an example where you won't be able to have, you won't be able to find all of your roots by using your rational root theorem. Okay, but you can double check. I have my x equals 0, my x equals 1, x equals negative 5, and x equals 2. Those are my 4 roots. My degree was 4. That tells me I'm done.